Hello everyone, today we team LMNTRIX from NITIE Mumbai will be presenting the case solution for 2015 Global Ptak Prize Case Challenge. My team LMNTRIX consists of 3 members, first me, Mohit Chandra, Suvajit Naskar and Rupam Josh. Without much ado, I will be taking you through my case solution. First of all, the case scenario. So the case describes the practical problems faced by Jim, a production manager of a lens manufacturing firm. The synopsis of a typical review meeting looks like the following table. So in this table there are 3 members from different departments. So they have claimed something and they have blamed some department, and there is an argument for this thing by Jim. So first of all, the Alan from sales department forecast 95% of that the forecast is 95% accurate. He blames the customer service which has been declined from 85% to 80% this year. So the Jim argues that the business revenue model forecast does not help sales promotional planning information required for effective decision making and increased safety stock due to the increased customer service. Deb from finance department blames the inventory level climbing high, and because of that the current cash flow is not good. And Jim argues that the revenue is up, so the inventory level is up. Larry, who is the division president, says that the product was easy, but Jim argues that SPC run chart and the CPK value shows the increasing in variability. Now this diagram shows about what are the process flow in the manufacturing of the lenses. As it was mentioned in the case, there are 2 types of lenses. One is spun lens and second is for astigmatism. So first of all, the monomer is dipped into optically grounded mold surface. After that, target value for the diopter is targeted, and then the polymerization occurs. After that, the hydrated and the tested, and finally the lenses are produced. For astigmatism, there is a slight change in the process. After the polymerization, microlathe operations are done, and after that the similar process carry on. The target diopter is minus 3.0, and we can see that the variation occurs from minus 2.5 to minus 2.7, and it goes on to minus 4.0. Now we have classified the case problems into 3 parts. First of all, the lack of accurate market forecast from the sales by SKU level for the lenses. Secondly, inventory level for different SKUs are increasing. And third, the variability of the production process increasing. For this thing, we have the following solution approach. First, in the demand planning, we'll be doing the clustering, then the proportional profiling. After that, the performance matrix. In inventory management, we'll be applying the theory of constraints. For that, we'll be using drum buffer rope concept, dynamic buffer management, and after that, we'll be calculating the buffers. In quality management, we'll be developing cause and effect diagram. After that, Pareto analysis, and then the design of experiments. First of all, in demand planning, as insight to the organizational overall forecasting process, aggregate forecasting gives us an insight to the organization's overall forecasting process. But disaggregating forecast by product and market attributes creates a powerful synergies between demand and supply planning. So as you can see in this diagram, there's a demand hierarchy showing for the multiple aggregations. For the demand disaggregation, following steps can be concluded. First of all, the SKU clustering. After that, proportional profile planning. Then the performance is measured by developing some sort of matrix. After that, the accuracy improvement is done. As you can see in this SKU clustering, we have taken the past data of 2 years, and we have taken the 8 types of SKUs. Then the clustering of the products have been done using the past demand data using SPSS software. As you can see in the output analysis, in cluster 2 we are having SKU 3, SKU 5 and SKU 7. Then SKU cluster have similar, we can see that they have similar demand pattern, hence can be easily disaggregated at SKU level analysis. Now for the proportional profile planning, as you can see on the right hand side, the proportional profiles can refine sub-SKU forecasts across every phase of the product life cycle. Multiple profiles can be used to adjust granular forecast and inventory to optimize sales and minimize obsolescence and discounting. The demand behavior of SKU within a profile or a cluster has to be analyzed at a different life cycle stages. A simple multi-tier proportional profile for the lenses has been shown. In this diagram you can see that there are lenses. Further it has been classified into two types that was given in the case, that is, one is spun lens and one is astigmatism lens. After that they have been further classified into three types: low, medium and high refractive indexes. In that each category we have 4 types of SKUs, contributing total 24 SKUs. Now in the performance matrices we have developed a matrix to calculate the performances. In this thing there are following steps. Step 1, to decide and forecast the accuracy metric, determine the level of aggregation, decide which attributes of forecasting process to store, apply relevant business. After that track the aggregated forecast metric, then apply the best forecasting metrics, and then repeat the result for the each period. Now waste determination and the improvements. First of all, we have done the MAPE, in which the error is coming out to be 55.81%. After that we have developed weighted APE, which is coming to be 21.34%. The weighting permits the forecaster to prioritize efforts at forecast accuracy improvement. In this, SKU 3 and 6 have the larger weights, and you can see that using WPE the error has been decreased from 55.8% to 21.84%. The major portion is taken by SKU 3 and SKU 6, hence they are the critical SKUs, hence the prioritization should be given to them. Now further on, the presentation will be carried by Suvajit.
Thank you, Mohit. Now I will be discussing about inventory management and the quality management approaches. Now increasing inventory of product which are not required is the major concern of GIM. To address this concern, the first thing required is a process map. The process map will give the nature of every activities performed. With this knowledge, we can identify the bottleneck activity. Here, testing being critical is taken as the bottleneck process, which will determine the throughput of the entire process. Here, drum buffer rope mechanism can be applied. The finished inventory buffer level will communicate to the bottleneck, which will in turn send a communication to the raw material. The entire process is depicted in the diagram. Here, the buffer needs to be available at the front of bottleneck to avoid loss of throughput, because we know that 1 hour loss in bottleneck process is 1 hour loss to the entire system. Now this diagram describes how drum buffer rope can be extended throughout the supply chain. Different color codes are used to determine different stock levels. For example, black is used to determine no stock, red for low stock, yellow for ideal stock, green for high stock, and sky blue for overstock. Now the replenishment at each stage is done based on consumption only. Hence the inventory is reduced at every stages of the supply chain. Now comes the buffer calculation. Now calculating buffer can be done using formula as shown in this diagram. So there are mainly 3 formulas. First one is concerning about buffer stock size or norm. The second one is suggested order quantity, and third is buffer penetration. Now to address the loss of inventory due to obsolescence, dynamic buffer management is proposed. Here different levels are varied automatically based on the actual demand, which checks the inventory. For example, for the first 3 period we can see that the buffer penetration reaches the red zone. Hence the buffer levels are automatically increased. Again, as the new buffer remains mostly in the green, the buffer size is automatically reduced. Hence this process will ensure inventory optimization. Now after inventory management, we come to quality management. The third issue which GIM faced was the huge variation in production process. The first tool which needs to be applied is cause and effect diagram, which will give the probable cause of the variations. For example, the different causes are analyzed by us, which are mainly the excessive polishing due to improper timings, the fast and deep cuts, improper diameter reduction, undesirable mechanical stresses, improper mounting on the lathe, exposure to heat and light, improper testing, improper purity and quality, excessive heat generation on lathe, and the improper spindle speed. Now, the one thing which has to be noted is that without the involvement of people who are actually doing the job, the process of constructing a cause and effect diagram is not fruitful. Now, the Pareto analysis needs to be applied to identify the factors which are critical for the variation. After identifying the 5 critical factors, we now proceed with the design of experiment. Now, in the design of experiment stage, we identify the different levels of the 5 factors which are identified based on the expert advice. Here, for example, we have 5 factors and 3 levels. So, for our case, L8 Taguchi design experiment is suitable. What this means is that we have to perform 8 experiments to determine all the possible combination of experiments. So, all the experiments are recorded and finally we come to the analysis. Now, in the analysis process, we look at the ANOVA table. The ANOVA table gives the relative importance of the factors. The factors for which p-value is greater than 0.05, these are significant factors and need to be taken care of. We then fit a regression line and check the goodness of fit using R-square value. Finally, we come to results. So in this result, we look at the main effect graph, which describes the optimal setting which is required for reduction of variation. The optimal settings are also depicted in a separate table. So from this we can say that if Jim applies the conducts a similar type of experiment and applies the optical setting, then he can drastically reduce the variation in the process. So finally, to conclude, we can say that we have addressed all the major problems which concern Jim. The approach are basically scientific and statistical tools and techniques, but only tools cannot improve any process. The proper coordination, involvement and awareness of all the stakeholders, right from the top management to the lower level employee, can only make the improvement process sustainable. Thank you.